Okay, so a linear programming problem. Let's read it together. The B&W Leather Company wants to add handmade belts and wallets to its product line. Each belt nets the company $18 in profit. Each wallet nets $12. Both belts and wallets require cutting and sewing. Belts require 2 hours of cutting time and 6 hours of sewing time. Wallets require 3 hours of cutting time and 3 hours of sewing time. If the cutting machine is available 12 hours a week and the sewing machine is available 18 hours a week, what ratio of belts and wallets will produce the most profit within the constraints? Whew! Okay, so I have belts and wallets. Let's start there. So we'll say B for belts, W for wallets. B is my number of belts. W, number of wallets. So, do you understand the situation? This is the company. They want to add some stuff to their product line, belts and wallets. They know how much they can get for each one, but it's going to cost a certain amount to create these things. So they have to use so many hours of their sewing machine, so many hours of their cutting machine, or whatever. Oh, I guess they're handmade, so I guess there's a cutter and a sewer person. And this is the times that they have allotted. Okay? So, let's see. Let's talk about our constraints. The first two are usually easy. Can I go negative? No, I'm not going to have negative belts or wallets, so both need to be greater than or equal to 0. Now, it tells me that both of these items require cutting and sewing time. So each one of those is a separate constraint. So as far as, let's deal with cutting first. If we go back and read, belts require 2 hours of cutting, and then look at wallets. Wallets require 3 hours of cutting. The cutting machine, oh, it is a machine, whatever. The cutting machine is only available 12 hours a week. So, belts require 2, wallets require 3, and I only have 12 to work with. Go ahead. You're close. Right, because each belt requires 2 hours of that cutting time. So, belts, 2B. 2 hours per belt is going to be used up in the cutting by the cutting machine, and wallets are 3 hours. So 3 hours are going to be eaten up by each wallet that we do, and I only have 12 to work with. So this has to be less than or equal to 12, because that's all the hours I have to use this cutting machine. The other constraint is the sewing machine. So see if you can do the same thing that we did with the cutting machine with the sewing machine. So go back and read them and see if you can give the inequality for this was for cutting, I want you to do it for sewing. You got it? Maybe, maybe not. Mm-hmm. Mm-hmm. Go ahead.
6B plus 3W is less than or equal to 18.
Sounds good to me. Each belt is 6 hours of sewing time, and then each wallet is 3 hours of sewing time, and I have 18 hours that I can work with on the sewing machine. Does that make sense? Is everybody okay so far? And I think those are all of my constraints. There's nothing else going on. I only have so many hours with the cutting and the sewing machines, but everything else seems to be fine. Yeah, okay, so we're ready to graph. we're going to create two axes. Oh. Good afternoon, Miss Sabia. Sure. No problem. Bye. Alyssa, you're being dismissed. Hopefully the rest of this video will record and you can watch and get caught up. Alright, so we're going to make two axes. We're going to have belts and wallets. I don't. 04. Trying to remember which one I put on the 6. Cutting. That makes no sense. 6. Yeah, okay. I put belts down here and wallets here. Okay, let me just, before I make my scale here, if I just look at my equations, this just tells me I'm in the first quadrant, and then if I just really quickly, if I cover that up, B is going to have to be 6, W is 4. Down here, I would need 3 and 6. So it looks like if I go up to 6 on each side, I should have enough. I guess I'll do every other line. 1, 2, 3, 4, 3, 4, 5, 6. Okay, and now I just need to graph my constraints. I don't really have to worry about B being greater than 0 and W being greater than 0 because I already did that by just being in the first quadrant. Okay, so cutting, let's see, if I plug in 0 for W, the B intercept would be at 6. So I'll put it down at 6 on my belt axis. If I plug in 0 for B, I would get 4 on my wallet axis. So I'll connect those two. All right, and then same thing for sewing. 0 for B, that would be 6 on the sewing axis, or on the wallet axis, and 3 for B. And 3. All right. So now I have my, huh? Yeah, let's make sure that I didn't mess up again. 3, 6. Yep, that should be right. All right, so now I have my feasible region. I want to be below both lines. So it's everything in this shape here. So these are all the possibilities that I could create given the time constraints. However, of course, if you're running a business, you want to maximize your profit. So although, sure, I could get away with making one belt, one wallet, I wouldn't bother because I want to make more money than that. So now all we need to do is look at our vertices and plug them into our objective function. We haven't written an objective function yet, so let's do that. How much money am I making from each of these things? Belts, $18, wallets, $12. So the profit will be
$30.
what?
And like if you made one belt
Well, I want an equation for however many belts and wallets I make. I'm making $18 per belt. 18B plus, you got it. So there's my objective function, and into that, I'm going to plug in my vertices of my feasible region. So one of them is 0, 4. Another one, that's going to be at, it's exactly at 1.5 on my scale, 1.5, 3. And 3, 0. Now, before we, what? Sure, sorry. Before we continue, can I even make 1.5 belts? Yeah.
So, sorry to backtrack.
No, it's okay.
For the points that we're finding, the ordered pairs, are we
Yep.
taking the vertices?
Yeah, the vertices of your feasible region. So that point, 0, 4. This point, which was 1.5, 3. And then this one's 3, 0. And again, 0, 0 is 1, but it's not going to make me any money, so I'm not going to bother. Can I make 1.5 belts in a week? Why not?
Because you don't want to sell something half a belt.
I can't sell half a belt, but I can make half a belt in a week. It's not ready for sale yet. Doesn't work that way. It's like you could read half a book in a week, right?
Yeah, I get it.
Right? So yeah, because think about it. They're hand making this thing. It's going to take several hours. So if you are this crafts person and you show up for work and you only got so far, usually you don't have to stay till you finish it. You're going to be like, okay, I'm coming back next week. I'll finish it next week. So, in theory, yes, you can make half a belt, but you can't sell half a belt. But since we're on the making side, we can stick with a half. All right, let's plug in our values and see what's going to make us the most money. Let's see. And B is X and W is Y. Yep. So 18, why am I? You guys can't see it that well when I use pencil. 18 times 0. Plus 4 times 12 times 4. That's going to get me $48 if I work it that way. Let's try 1.5 and 3. That's going to get me 27 plus 36, $63. Or I could focus on just belts, no wallets. 18 times 3, $54. Here's actually a great question now. So let's say it's it's normal average week. I'm going to try and make 1.5 belts and 3 complete wallets. Let's say, however, I'm about to leave for for a festival. So I'm just going to take my inventory with me and I'm going to sell it. Well, maybe that week I don't make 1.5 belts because I can't take that half a belt with me to sell it. So maybe that week I say, you know what? I'll just drop down to this one because that makes more sense. Here I'm going to lose a whole $18 if I can't produce that other half of the belt. So why don't I go to this one? Okay? So it will kind of depend on your situation for the week. Just a thought. Does this make sense? How this all works? Let's try a cost one, and I think that might be all that we have time for. All right, so the third one is a cost problem. So let's read and see if we can figure this one out.